કેમ છો બધા? In the last lecture, we have discussed prism. So first, recall various equation. So what is prism? So it consists of two refracting surfaces which are not parallel. આ એનું શું છે? Cross section. So equilibrium બરાબર. આ બે surface કેવી હોય છે? Parallel હોવી જોઈએ નહીં. So angle of prism A. અને એના પરથી આપણે equation derive કરેલું. તો equation શું હતું? તો કે A is equal to R1 plus R2, I plus E is equal to A plus delta. What is delta? So delta is angle of deviation. Okay. So then for maximum deviation, so no need to remember this equation. For minimum deviation, rays are parallel. તેના માટે શું આવશે? તો કે I is equal to E. તો એ વખતે R શું થશે? તો કે A by 2 અને I શું થશે? A plus delta M by 2. So mu is equal to, so remember this equation. So delta M is equal to A. Okay, mu cosec A by 2. Normal incidence હોય તો આ 0 હોય I તો R શું થશે? 0. તો R2 is equal to automatic શું થઈ જાય? A. આમાં પણ condition કેવી આવશે? તો કે R2 is equal to 0, E is equal to 0, તો R1 શું થઈ જશે? A. અને same grazing emergence અને total internal reflection. So normal incidence થતું હોય ત્યારે so if આ જે angle છે, if A, so R is equal to A and that is equal to C, તો શું થશે? Grazing. If A is less than તો 12 આવશે અને if A is greater than C તો ક્યાં આવશે? તો કે total internal reflection. ઓકે, એવી રીતે grazing incidence થતું હોય અહીંયા શું આવશે? તો કે A minus C. So if A is equal to 2C, A greater than 2C, A less than 2C. So A less than 2C, ray 1 is equal to 2, ray 2 and less than to ray 3. Okay. Similarly, dispersion through the prism. Okay, so splitting of white light into constituent color, that is called dispersion of light. So you can see the white light. Okay, you can see dispersion. So my maximum bending, that is for violet, and minimum bending for that is for red. So delta R and delta violet, and one more delta Y, so that is yellow, and that is mid. Okay, so angular dispersion, so that is separation between two extreme color. Theta is equal to delta V minus delta R, so that is mu V minus mu R into A. And angular dispersion, similarly dispersive power, so dispersive power is equal to mu V minus mu R upon mu Y minus 1. So mu Y is mu V plus mu R divided by 2. Okay, so when we use combination, okay, so combination, so dispersion without deviation. So dispersion without deviation, for that A dash by A is equal to mu Y minus 1, mu Y dash minus 1. So inversely proportional. Okay, and deviation without dispersion, then we can say mu V minus mu R, mu V dash minus mu dash R. Okay, so let us consider examples. Okay, so these examples are basic example. Generally NEET માં જે examples પૂછાશે એવા એકદમ simple examples જ હશે. So ray of light passes through an equilateral glass prism. So equilateral, it means A is equal to 60 such that angle of incidence is equal to angle of emergence. It means I is equal to E. Angle of incidence is equal to angle of emergence. If the angle of emergence is 3 by 4 times the angle of prism, so E is equal to 3 by 4 times A. E is equal to 3 by 4 times angle of prism. Calculate angle of deviation. So calculate delta. In second, the refractive index mu. So first delta. So now equation for delta is A plus delta is equal to I plus E. Okay, so now I is equal to E, so I can say 2 into E. So now E is equal to 3 by 4A. So 3 by 4, A is equal to 60. Okay, so I can say 15 into 3, so that is E is equal to 45 degree. So now I can substitute delta is equal to 2 into 45 minus A. A is equal to 60. So 90 minus 60, 30. The angle of deviation delta is equal to 30. Okay, so now refractive index. So refractive index mu. So mu is equal to, so here it will say and I is equal to E. So that is for minimum deviation. So you can write the equation mu is equal to sine A plus delta m by 2 upon sine A by 2. Okay, so this is for minimum deviation. When I is equal to U, you can write mu is equal to, so now A is equal to, so A is equal to 60 and delta is equal to, 30. So 60 plus 30 by 2, so sine 45 divided by sine A by 2, so sine 30. So sine 45, 1 upon root 2, 1 upon root 2, sine 30, 1 by 2. So 2 upon root 2, so answer is root 2. So mu is equal to 1.4, mu is equal to root 2. Okay, so by using the equation easily, you can solve any examples. So next example, a ray of light incident on equilateral glass prism, so A is equal to 60, shows minimum deviation of 30 degree. So delta M is equal to 30 and A is equal to 60. Calculate the speed of light through the prism. So speed of light C. So equation is, so mu is equal to V by C, mu is equal to V by C. Okay, so if you want to calculate the speed of light V, okay, so then you can find out, so if C is equal to, so 3 into 10 raised to 8 divided by mu is equal to, you will get V. So how can we find mu? So mu you can find sine A plus delta M by, okay, so now you can do it very easily. Next example, so calculate the angle of minimum deviation delta M. Calculate delta M, angle of minimum deviation for an equilateral triangle. It means A is equal to 60 of refractive index, mu is equal to root 3. So we want to find out delta M. A is given, mu is given. So equation mu is equal to sine A plus delta M divided by 2 upon sine A by 2, and that is equal to, so mu is given root 3. Mu is given root 3. A is equal to 60. So write down here. So sine 60 plus delta M by 2 upon sine 30 is equal to root 3. So sine 30 is 1 by 2. So I can say here, so sine 60 plus delta M by 2 is equal to sine 30 is root 3 by 2 and root 3 by 2. So here it is sine. So I have to consider sine. So sine 60 root 3 by 2. So sine. So now I can consider 60 plus delta M by 2 is equal to 60. So delta M is equal to 120 minus 60, and that is equal to 60. So delta M minimum deviation, so that is 60. Okay. So next example, a ray PQ incident on the face AB. So you can see face AB, ray PQ on prism ABC as shown in the figure. The emergence from the face AC, the emergence from the face AC such that AQ is equal to AR. So AQ is equal to AR. It means this rays pass through the prism horizontally, because these two sides are, so pass through the prism horizontally, or you can say this ray is QR is parallel to BC. Okay, so now from this you can understand this is the condition for minimum deviation. Draw the ray diagram showing the passage of ray through the prism. So you can draw the ray diagram. Okay, so you can extend this, you can get, and here you can get again, draw the perpendicular, draw perpendicular, R1, R2, everything you can mention. So if the angle of prism 60 and refractive index of the material of the prism is root 3, determine the value of angle of incidence and angle of deviation. angle of incidence and angle of deviation. So angle of deviation, so that is delta. So how can we say? So here the ray is parallel to base. So I can say I is equal to E. So I is equal to E. So now delta is equal to I plus E minus A. Okay. So I is equal to E. So it means 2I minus A. So A is equal to given 60. Okay. A is equal to 60. But mu is equal to root 3. Okay. So we can find out I. Okay. So I. So that is mu is equal to sine A plus delta m by 2 upon sine A by 2. So here delta m is given, not given, but mu is given. So mu is equal to root 3 is equal to sine 60 plus delta m by 2 upon sine 30. Sine 30 root 3 by 2. I can write here root 3 by 2. I can write here 60. So from this same example already we have solved. So delta m is equal to 60. Delta m is equal to 60. So from if delta m is equal to 60, so 60 plus 60 divided by 2, so that is equal to I. So I is equal to 60. So I is equal to 60 and that is equal to E. Okay. So 2I minus A. So 60 plus 60 minus 60. So that is again 60. Okay. So first find out, determine the value of angle of incidence. So that is I, and angle of deviation. So that is delta. So both I is equal to 60 and delta M, that is also equal to 60. So examples are comparatively simple. A ray of light PQ is incident at an angle 60 degree on the face AB of angle of prism 30. You can see angle of incidence 60, angle of prism 30 as shown in the figure. The ray emerging out of the prism makes an angle 30 degree with incident ray. The ray emerging out from the prism makes an angle 30 degree with incident ray. So that is angle of deviation. So delta m. So delta is given. We don't know whether it is m or not. So delta is 30 degree. So that the emergent ray is perpendicular to the face BC through which it emerges. So if we consider face BC, then this emergent ray should be, so it means angle of emergent E should be 90. Sorry, E should be equal to either 0 or this angle should be 90. Also calculate the refractive index of prism of metal. Okay. So now delta is given, A is given, I is given. So equation is A plus delta is equal to I plus E. So E is equal to A is equal to angle of prism, so that is 30, delta, so that is also 30, minus angle of incidence, so that is 60. So angle of emergent is 0. So now you can see E is equal to 0. It means emergent ray is perpendicular to face BC. Emergent ray is perpendicular to face BC. And mu. So now you can calculate mu very easily. Mu is equal to, so if this angle is 90 degree, then again R, that is also 90 degree. So E is equal to 0, R2, that is also equal to 0. So A is equal to R1 plus R2. So R2 is equal to 0. It means A is equal to R1 and A is equal to 30, then R1 is also equal to 30. So I can say mu is equal to sine I upon sine R1. So sine I, so sine 60 upon sine R1, so that is sine 30. So sine 60 is root 3 by 2 and sine 30 is 1 by 2. So answer is root 3. So mu is equal to root 3. Mu is equal to root 3. So here you can see the examples are very simple. Your concept must be clear. A glass prism of refracting angle 60 degree and refractive index 1.5 is completely immersed in water of refractive index 1.33. So glass prism is completely immersed in water. Calculate the angle of minimum deviation of the prism in this situation. So already we have discussed mu is equal to angle of minimum deviation. So I can write sine A plus delta m by 2 upon sine A by 2. So we have written this equation. So here there is one side there is a air, on second side there is a glass. But here the prism is placed in water. So instead of air, I have to write here water. So mu of glass with respect to water. So for that I have to write mu g by mu double. Okay. So now angle 60, refractive index 1.5. Okay. So now I can consider sine 60 plus delta m by 2 is equal to mu g, so that is 1.5, mu of water, so that is 1.33 upon sine 30. Sine 30 is into 1 by 2. Okay, so sine inverse 0.56 is given. So naturally here if I will consider 0.75 divided by 1.33, so naturally it should be 0.56. Okay, so sine inverse 0.56, so that is 34.3. So I can write 60 plus delta m by 2 is equal to sine inverse 0.56. So sine inverse 0.5 is 34.3. So delta m is equal to, so 34 into 2, 68.6 minus 60, so that is 8.6. So delta m is equal to 8.6. Okay, so now remember, so if prism is in the water, so here instead of mu we have to consider refractive index of glass with respect to water, or whatever may be the fluid outside the prism. Okay, so generally we will make mistake over here. So one face of a prism of refracting angle 30 degree and refractive index 1.414 is silvered. At what angle must a ray of light, so angle of prism that is given, let me draw it. So angle of prism, so that is 30 and refractive index 1.41. At what angle must a ray of light fall on the unsilvered face? Okay, so consider one face is silvered. Okay, so that after refraction into the prism and reflection at the silver surface, it retraces its path. Okay, it means it retraces its path. So consider, suppose at silver surface. Okay, so you can say here the angle of incidence I. So what should be the angle of incidence? The ray retraces its path. Okay, so if it retraces its path, this angle must be 90 degree. Okay, it means E is equal to 0. So I can say R2 is equal to 0. So if R2 is equal to 0, E is equal to 0, then A is equal to R1. A is equal to R1 and A is equal to 30. It means R1 is equal to 30. R1 is equal to 30. So our aim is we want to find angle of incidence I. So mu is given. So mu is equal to sine I upon sine R. So sine I upon sine R. So mu is equal to, so 1.414 into sine 30. So sine 30 is 1 by 2 is equal to sine I. Okay, so divide it by, so 1 point, so here you can say approximately 0.707 is equal to sine I. Okay, so from the table we can calculate angle of incidence I. Okay, so if this example will be asked, then the value will be given, so no need to worry about the value. Okay, so answer is, you can find the value R. A thin A thin of refracting angle 2 degree deviates an incident ray through an angle of 1 degree. So delta M 1 degree and A, that is equal to 2 degree. Find the value of refractive index of material of the prism. Okay, so here 2 degree is very small. So we know the value. So mu minus 1 into A, that is equal to delta. Delta is equal to mu minus 1 into A. So now what is given? So incident ray delta is given, so that is 1. Okay, and refracting angle of, so A is given, so that is 2. So we want to find mu. So mu is equal to, so first delta by A. So delta by A plus 1. Delta by A plus 1. So delta is equal to 1, A is equal to 2 plus 1. So that is 1 by, so that is 1.5. 3 by 2. So mu is equal to 1.5. It means material is glass material. So for small angle, we have to use this equation. So that the angle of minimum deviation produced by the thin prism is reduced to 1/4 with respect to air when it is immersed in water. Okay, it means delta 2 by delta 1, so that is 1/4. Okay, so so for delta 1 calculate considering mu in air, delta 2 consider mu with water. Okay, and take the ratio, so you will get the answer. Okay, so you can use the equation delta is equal to mu minus 1 into A. So you can do it. A prism with refracting angle of 60 degree gives angle of minimum deviation 53, 51, 52 for blue, red and yellow light respectively. So what is the dispersive power of material of the prism? So dispersive power omega, omega is equal to, so what is given? Angle of minimum deviation. So you can say delta blue minus delta R upon, okay, upon omega. Omega is upon delta y minus 1. So you can say, so that is delta first one for blue. So for blue it is 53 minus yellow, red and yellow. So yellow, so that is 51 upon yellow. So yellow is 52 minus 1. So 52, so 2 upon 51. So 2 by 51. So that is the dispersive power of the material of the prism. So you can calculate. Refractive indices of the flint glass of blue and red color are 1.664 and 1.644. Calculate the dispersive power. Okay, so dispersive power omega. So omega is equal to, so mu blue, so mu b minus mu v upon mu y minus 1. So now mu b, so that is given 1.664 minus 1.644 upon mu y. So mu y is not given, so you can consider mu y. So that is average of these two. So 1.664 plus 1.644 divided by 2. So 644, 664, so 1.654. So I can write here 1.654 minus 1. So this is the dispersive part. So generally you will find simple example from this topic. Okay, so now you can see the examples from the material. The angle of minimum deviation for a prism of refractive index 1.5 is equal to angle of prism. So delta M is equal to A. The angle of prism is, so find out the angle of prism, it means find out A. Okay, so now mu is given, so here equation, so it should be mu is equal to sine A plus delta M by 2 upon sine A by 2. So here condition is delta M is equal to A, so A plus A divided by 2, so sine A upon sine A by 2. So sine A by 2 and sine A. So now I can say sine A by 2 cos A by 2 into 2. So 2 sine theta by 2 cos theta by 2. So you can say final answer is 2 cos A by 2, and that is equal to 1.5. So 1.5 divided by 2, so that is 0.75 is equal to cos A by 2. So cos 0.75, so 0.75 is equal to cos 41. So I can write here cos 41. So remove cos, it means A by 2 is equal to 41. So A is equal to 82. A is equal to 82. Okay. So refracting angle of prism is A, and refractive index of material of the prism is cot A by 2. Mu is equal to cot A by 2. So angle of minimum deviation. So here we can use the equation. So mu is equal to sine A plus delta M divided by 2 upon sine A by 2. And mu is given, so mu is equal to cot A by 2. So cot A by 2 is cos A by 2 upon sine A by 2. So sine A by 2, sine A by 2 cancel. So I can say sine A plus delta M by 2 is equal to cos A by 2. So if I want to remove the sine, okay, then I have to replace this cos into sine. So cos A by 2 is sine 90 minus A by 2. So sine 90 minus A by 2 is cos A by 2. Okay, so now I can say A plus delta M by 2, that is equal to 90 minus A by 2. Okay, so delta M is equal to 90 into 2, so that is 180 minus A, and again A, so that is 180 minus 2A. So 180 minus 2A. You can see. Okay, એક્ઝામ્પલ કેવો દેખાય છે? સિમ્પલ, પણ થોડું મેથેમેટિક્સ આવડવું જોઈએ. લાસ્ટ એક્ઝામ્પલ મિસ કર્યો, નહીં આવી. So PQR is right angle prism. You can see PQR is right angle prism with other angles as 60 and 30. So 60 and 30. Refractive index of prism, that is 1.5. PQ has thin layer of liquid. So on this surface there is a thin layer of liquid. Light falls normally on the face PR. So light falls normally on the face PR. Normally means the angle of incidence 0, angle of refraction 0. So if angle of incidence 0, angle of refraction 0. Okay. So for total internal reflection, maximum refractive index of liquid. Okay, so if this angle is 0, so for total internal reflection you can say angle theta. So for total internal reflection, theta should be greater than C. Theta should be greater than C. Okay, so what should be the theta? So if this angle is 60, 90, and then naturally this angle is 30. So if this angle is 30, so this total angle, so that is 90. So it should be theta is equal to 60. So theta is equal to 60. Okay, so theta must be greater than C. Okay, it means sine theta must be greater than sine C. So sine theta, so that is sine 60 must be greater than sine C. Sine C, so that is equal to 1 upon mu. Okay, so for total internal reflex, so instead of greater than, or we can use equal to also. So mu is equal to 1 upon sine C, 1 upon sine 60. So sine 60 is root 3 by 2. So 2 by root 3. So 2 by root 3. So value 2 by root 3. So 2 by 1.7. 1.7. Okay. So you can consider approximately 1.3. Okay. So refractive index is 1.3. So is this correct? Not correct. Okay. Why you are making mistake? Because I have written only mu. So mu, that is applicable if it is air, but here there is no air. Okay, so you have to consider here mu of, so initially what we are considering, so rays is entering, and so here suppose in case of glass, so ray is entering from the air to the glass. Okay, so here we are writing refractive index of glass with respect to air. So here I have to write refractive index of liquid with respect to glass. So here I have to write mu L upon mu glass. So find the refractive index of liquid. So mu L is equal to, so mu L is equal to, so 2 upon root 3 into refractive index of glass. So refractive glass, so that is given, yes, that is 1.5. So now you will get exact answer 1. Okay, so whenever you find liquid, okay, so take care. Okay, always you will make mistake. So mu L by mu G, you will get answer 1.3. Two identical prism 1 and 2, each will angle 30, 60, 90. So 30, 60, 90 are placed in contact as shown in the figure. A ray of light passed through the combination in the position of minimum deviation. So in the position of minimum deviation, it means this ray is parallel to base and suffer deviation of 30 degree. So delta M is equal to 30 degree. If the prism 2 is removed, so now remove this prism, then angle of deviation of the same ray. And angle of deviation, answer smaller than 30 equal to 15, more than 15 equal to 30. So angle of deviation delta, so that is equal to mu minus 1 into A. Mu minus 1. So here material is same. It means delta is proportional to A. So initially angle of prism, so that was 60. Now when we remove the first part, angle of prism is 30. So instead of A, so it is A by 2. Then answer should be delta by 2. So delta is 30. So 30 by 2. So it should be 15. So that is equal to 15. That is equal to 15. A prism having an apex angle 4 degrees, so angle of prism 4 degree, and refraction index 1.5 is located in front of vertical plane mirror. So you can see here plane mirror as shown in the figure. Okay, so ray incident perpendicular to the face, or to the first face. Okay, so now incident to the second, and angle of deviation through what total angle is the ray deviated after reflection from the mirror. So first angle of deviation 2 degree. So now it incidence on the mirror at angle 2 degree, and again after reflection, so angle of incidence should be equal to angle of reflection, so that is 2. So what is total angle is the ray deviated after reflection from the mirror. So original direction, so this is the original direction. So from the figure also we can say, so this is original direction. So you can see this is original direction. So now you can see, so this is total or final angle of deviation. So now you can see, if we draw horizontal line, this angle is 2. So answer is 180 minus 2. So that is 178. 178. Okay, so with the help of trick we can find out. Okay, otherwise we have to consider delta total. So that is delta prism plus delta mirror. So delta prism, so that is given. So delta by the prism, that is equal to 2, plus delta mirror. So delta mirror. So if we consider mirror, then draw yellow line. Okay, suppose blue line. So for the mirror, 180 minus 2i. 180 minus 2i. So 2 plus 180 minus 2 into 2. So that is again 178. Okay, so with the help of trick also it is 178. With combination of prism and mirror, that is also 178. A ray of light is incident to hypotenuse of right angle prism after traveling parallel to the base inside the prism. Okay, so hypotenuse to the right angle prism. You can consider right angle prism. So ray of light is incident to the hypotenuse of right angle prism after traveling parallel to the base inside the prism. So parallel to the base. Okay. Now you can see incident ray. If is the refractive index of material of the prism. So if consider here mu should be written. So mu is the refractive index of material of the prism. The maximum value of base angle for which light is totally reflected from hypotenuse. Okay, so if we consider angle of prism, so that is alpha, one angle is 90. So naturally other angle should be 90 minus alpha. One angle is alpha, second should be 90 minus alpha. Okay, so if I will draw perpendicular, so for total internal reflection, this angle theta, this theta should be greater than C. This theta should be greater than C. So C, okay, it means sine theta should be greater than sine C, and that is should be equal to sine C is 1 upon mu. Okay, so now sine theta should be greater than 1 upon mu. So what should be the angle theta? Okay, so if angle of incidence 0, angle of reflection 0, so both are 0, 90. If this angle is alpha, naturally this is 90 minus alpha. So if one is 90, 90 minus alpha, so this angle is alpha, and again theta should be 90 minus alpha. So sine 90 minus alpha should be greater than 1 upon. So now I can say 1 upon mu. Sine 90 minus alpha should be greater than 1 upon mu. So sine 90 minus alpha is cos alpha should be greater than 1 upon mu. So alpha should be greater than cos inverse 1 upon mu. So sine cos inverse 1 upon mu. Okay, so alpha is cos inverse 1 upon mu. Okay, so already we have covered this part in theory. So now easily you can solve the example. I think I have covered almost all examples. Okay, so our one small topic is remaining, so that is error. So that part we will cover tomorrow. So thank you very much.